to thank organizer for possibility to be in such wonderful place. Now my talk, where I have seen in the lecture that was in the summer the lean talk on periods or some iterated integrals. So I don't know if I say very much original, but at least I will be talking about elladic parts. But I start just like Professor Wojtkowiak with 0, 1. So if we consider this pair, it has good reduction everywhere. And this is the numbers, which I write like this. These are iterated integrals in these two forms, in this one forms and sequences of one forms, dz minus 1 and dz. And these iterated integrals are known to be periods of mixed Tate motive over spec z, because it has good reduction associated with pi 1, 1 infinity, and this base point. So there's natural question if you have any mixed Tate motive over spec z, whether in this way you get all periods or whether there are some other. So I shall write question where the these numbers are all periods of mixed Tate motives over spec z. Well, a similar example one can consider pi 1 minus 0 infinity 1, and the base point one take p prime number, and one consider the periods of mixed Tate motives here. So it has good reduction everywhere outside p. So once more one consider this iterated integrals in this form, but one should start whatever this means from such thing. And in this two in sequences in this one forms, and one obtains this number. Essentially this will be these numbers, and one additional is logarithm p. And one can ask once more whether one obtain all periods of mixed Tate motives over spec z with 1 over p with p inverted. So I don't know answer on this question, but I will give some construction, at least in elladic case, how to get all this periods. Elladic for me means Galois side, so it's not ultrametric and so on. So first I should reformulate this question somehow in language of Galois representations. So well, I start with such general to just pose a question. If this is absolute Galois group over Q, we have representation, and we have coefficient phi g, some coefficient of this representation. We can ask question once more whether this phi, this representation phi appears as a Galois representation on some geometric object like pi 1, or some quotient of pi 1 on hi, and so on. So And the same thing, one can ask whether only this coefficient, one of the coefficients, appears as the coefficient of some representation of GQ on, well, of course, I cannot say nothing about this general problem. So I will discuss only some very particular case. So L is a prime number. It is a fixed prime number. K is a number field. S is a set of finite places of K. And I will studying next Tate representation of GK unramified outside S plus all primes of K which divide L. So I can write them like that. And Tate means that it's a weight filtration, and if you take subquotient, it will be a direct sum of Qi, something like that. So here it's a very good situation by result of Hein and Matsumoto, which proved that every such representation factorize, so any such representation factors through a pro-algebraic group over QL, well, the representation which I consider are, I should say, in QL vector spaces. So any such representation factors to a pro-algebraic group over QL, and this group they call weighted Tate completion of I would like that spec O K S plus, so there are K integers in K which allow this to be advertible. So this is a Galois group of K which allows only this ramification, and pro L well, I should say when it appears pro L because in QL vector spaces, and so such representation factors to a pro-algebraic group over QL, which they call weighted Tate completion of, or take it QL, perhaps completion of the things, and I will denote this group. We denote it by O K S plus L, and here L, because we are using L. Then there's an exact sequence. This L into multiplicative group, and here is U O K. The kernel is we denote like that. L, L, and L here. Well, this is a kernel, and you have such exact sequence. And this is equipped with weight filtration, and if you take associated graded first Lie algebra, and then this L, so it becomes 3, and a dim of this thing, S plus L, L tensor with Q, so it's a vector space, generators in degree 1, and dim H1 K Q L E generators in degree E. So it's just very well known. This is a result of Matsumoto. And in fact, these generators, so G U O K S L L in degree 1, so generators are dual, elements dual, where you choose a base here, so element Z base here, and you take Kummer character of this Z base, and you take a dual. So these are generators are just dual of Kummer characters. So when it says something to erase, oh, I don't see. Oh, here is a lot of. Oh, I still can have something. So, in fact, the Haine Matsumoto has a better construction which can deal without these things, but I really don't know how to do it, so I should make some modification. So I consider only such action, such thing, n infinity and some v, and AE and V belongs to K, eventually V is a K base point defined over K. And we assume that has good reduction outside S. This was this S here. So now,
in this cohomology group, is it passes unramified outside
here?
H1, yeah.
Yeah, this does not change. This will be the same, I think, by some result of Sule. Okay, S plus L, at least as I understand. This will be the same, QL. If this appears, then this will be the same. So the only thing which change, I think, is in dimension 1. That in dimension 1 appears more generators. So now GK acts on pi 1 V K bar V pro L completion. And I get, when I pass to associatedly, usually I'm embedding pi 1, I embedded it in such thing. This somehow is better in such a way that the loop around AI, xi, goes to exponential xi. So if I pass then to this algebra, I get such thing. V Li U O K S plus L L L to Lie algebra. The Galois action on here induced Galois action on here. So you go to automorphism and then to Lie algebra. So I can write like that to this a non-commutative power series in n variable formal power series. So I get something like that. V. And now it's such thing that here in degree 1, I have elements which are dual, generators are dual to OKS plus L star Z base I choose, and Kummer characters, and then dual. So, and here it appears that I can prove theorem with this assumption that in degree 1 of the morphism appear only Kummer character T for T belonging to OKS star. So now I can do such thing. I can take this thing. I can take Z base here, A1, AN. I complete this to Z base of these things, T1, TR. Then the generators here in degree 1, they are dual. And by such this morphism, all these generators go to 0. And this happens always with this assumption. So I take an idea generated by these things, which I don't need, and I divide it. So So I take, and this what I get, I will denote by, after division, by these ideals. So this U, O, K, S plus L, 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 divided by this ideal. I will denote by, this I should, L. So these things will disappear. And now the number of generators in degree 1 is just OKS star tensor Q D. So this will be a number of generators in degree 1. Number of generators in degree 1. And now, of course, I will get once more the morphism, which I can denote like Z2 and the morphism of this, non-commutative polynomial algebra. And now I shall define what I mean by what I mean by the periods or analogs of periods of mixed state motifs over spec. So what I mean by analogs of periods of mixed state motifs over spec OKS. So definition, I will take this space. This is a graded vector space, and each dimension is finite in each dimension. So I take Li U O K S L, and then the dual. In each dimension, I take a dual space, and this is the space of coefficient on LUOKS, or this I will also call the space of L-adic Galois periods over the space of L-adic Galois periods of Galois periods of mixed Tate motifs over spec OKS. Well, why this has this correct dimension? Because in mixed Hodge theory, by some, I think, formalists, you get also this kind of group which has the same dimension. You take a Lie algebra, then you have two lattices which you have compared. So if you take a linear functional on this in the RAM Hodge theory, it will always give a number, and you will have the number of linear functional, linear independent is the same as here. So you will have the number of different numbers which you get as a periods will be more or less will be the same. So this, I think, is a very good analog. Another good analog, perhaps it should be better also use just whole Lie algebra and dual in some sense, or use just this group, OKSL, and use algebraic function. But more or less they are equivalent, but this is the most weak form, but still it's. Now, if psi belongs here to endomorphism of QL x1 xn, then I take a composition, so phi v composed with psi belongs to UOKSL, and we call it geometric coefficient coming from this pi1 minus from how it was notated, v or pi1. So you see now, if I have here a linear form psi to ql, by composition I obtain some elements here. And the question is, are all coefficients of LUOKSL geometrical in this sense, which I define, so that they come as a coefficients of some representation. So this is more or less the same question which I asked at the beginning. Are all periods of mixed Tate motif over something iterated integrals, if I stick to this form. So here is one example, which of course I don't know answer. Are all elements of Lie Z. So this was our original example, pi1 minus 0 infinity. Geometrical coming from pi 1 minus 0, 1, infinity, 0, 1. So the answer is if this map to derivation, because this image is usually very smaller, so in fact it's some special derivation. If this map, which is induced, is injective, then of course yes, but this I don't know. And the same, still I mentioned some example which I mark. So you consider the action on pi 1 q bar minus 0 infinity plus mi phi 0 1 L, and then you have this map. This has good reduction everywhere outside 5. So you have this map Li U Z mi 5 1 over 5 L to endomorphism of QL, and this is x, y0, y4. And this map is not injective. I will speak a little more at the end. So, one cannot expect, well, perhaps here one still can expect, I don't know, but in general not. So one must do something else. So here is some equation which is well known. 1 minus p n minus 1 sum k equals 1 to p minus 1 len. This is a primitive p roots of unity to k. So there's such equation, and these are classical polylogarithms. So I recall that they are iterated integrals in any way. Or 1 minus z dz dz. So these are these periods. Oh, here should be z. So what we have here, coefficient or period over q, over spec q, and here we have over spec z or q mi p. And Zagier has, when he was studying his Zagier conjecture, wrote more. This comes from functional equation, but he wrote some more such type equalities. That on one side you have smaller fields, and on one other side you have bigger fields. So we can hope now that perhaps all this period. So I should erase something. So we can hope perhaps that periods of mixed state motifs over spec z, or these coefficients, which I rather use, coefficients, can be get as a sum of some periods or coefficients over spec of some bigger field, some p or some bigger fields. So we shall look now at more general situation. So here you have such situation that you get period or coefficients over q as a sum of coefficients over. So we can hope that perhaps this could be a general case. So now L, finite Galois extension of K, T is a set of finite places of L lying over S, over places from S. So S finite places of K. And then the mixed Tate representation of GL unramified outside T plus the prime which divide L in L. No, it's an inverse way. Of GK. Of GK unramified outside this induces a mixed Tate representation of GL unramified outside T plus LL. So we get a surjective morphism if we first from OLT. Oh. So you get amorphism. In fact, before you get amorphism on this group, which on the weighted Tate completions, and then after passing you get, and this morphism will be surjective. This can be seen perhaps directly when you look on our cohomology because of number fields, because generators are dual to cohomology. And similarly, if S is contained in S prime, and this is also a finite set of places of K, then you get something like the, this map I should denote P, KS, LT, and you get something like P, KS, KS prime from Li, U, O, K, S prime, L to W, Li, U, O, K, S, L. And this will be also surjective. So you can observe now you can observe now that if I pass to dual, I have a map from P, KS, LT, dual, W, Li, U, O, KS, L, dual, and it will be injected into Li, U, O, L, T, L, dual. And the same situation happened in this can be identified. This F will belongs to Li, U, O, L, T, L, dual, and such that it vanishes on the kernel of this morphism. Okay, SLT on this kernel is 0. And similarly, we have R, W, L, U, O, K, S, L, 2, injective 2, L, U, O, K, S prime, L. And this is F, which belongs to this bigger U, O, K, S prime, and F vanishes on kernel of this morphism, P, K, S, K, S prime is 0. And of course, such F, which belongs here to this bigger, we can call that F is unramified outside S. So this would be also like that I can write. Well, this is just definition that F will belong here, but a 0 on kernel I can call really unramified outside S. And now I will be studying on a very particular case, in fact. Like so, I will try to get periods over spec Z over spec Z1P by this method. So please notice that it gives elements the coefficients here, one get as the coefficients here, which vanishes on the kernel. So in general, the coefficient here can be interpreted as the sum of coefficients here. But if here are not geometrical, these are also not geometrical. So for the moment, it does not help very much. So I will be studying this map. Gerwu, Li, U, Z, Mi, P, 1 over P. L, P, L, U, Z, 1 over P, L, and then W, L, U, Z, L. These maps are surjected. It's generators in degree 1. In degree 1, generators are K, 1 minus CPI, where I is between 1 and P minus 1 over 2, and dual to this. Here the generator is only 1 in degree 1, is dual to the Kummer character of P, and the map from this formula, product 1 minus CPI E equals 1 to P minus 1, one can notice that this generator goes to 2 P star. So everyone goes like that here. And now I consider the Galois action of G, Q, Mi, P. This Galois group acts on pi 1 of projective line Q bar minus 0 infinity plus mi P. P is a prime number, 0, 1, L. So if I pass to graded group, this has good reduction everywhere outside P. So I get a morphism from Li, U, Z, mi, P, 1 over P, L, two endomorphisms. So here you have 0, which I embed to EX, and here you have 1, CP1, which I to EY0, EY1. So here I will have, in fact, there is this endomorphism is usually very small. So it's a derivation group of a freely algebra, P minus 1. And in fact, this derivation group one can replace by this Lie algebra, free Lie algebra, but with some other brackets, which I will say perhaps after. And this map, which I denote like Z, is not injective. Not injective in general. I have given example.
Generalize this example? Example, generalizing?
No, it's yes, but in general it's not injective.
But relation to this example?
Well, this is a special case for PA. So this map is in general not injective, but what it means that periods of mixed state motif over spec mi p 1p, one cannot expect to obtain all periods of mixed state motif over these things as iterated integrals from 0, 1 to 1, 0 in this form, dz over z and dz, z minus xp I, and I equals in sequence of this one forms. So this one cannot expect, but I still will try to get these things. So now I'm looking at the following diagram. W, Li, U, Z, Mi, P, 1 P L. Here is W, Li, U, Z, 1 over P L. Here I have this phi 0, 1 to Li x, y 0, y p minus 1 with these brackets. And here I have image phi 0, 1, which is contained. So here you have also phi 0, 1, and here is p. And we have a proposition. If ker phi 0, 1, so this map is contained in ker p, then because this map are surjective, then exists unique psi. So this psi such that p equal psi composed with phi 0, 1, 1, and passing to dual vector spaces, we get that GRW Li U Z 1 over PL and dual. This would be, if this is surjective, so this became also surjective, and in this way, this dual will be embedded in the dual of this, which is embedded in the dual of this. So I get that this will be f belonging to Lie x y0 y p minus 1 dual. So this, say, elements here are iterated as a periods. If I look, these are iterated integrals in these forms, and sum of such iterated integrals. And then if I compose with phi 0, 1, so these are only geometrical, because if I have f here to ql, so it gave something here so I get elements here, and if these elements f phi 0, 1 will vanishes on curve P. So this, if I extend my definition of something being geometrical in this way, I will get that all elements here are geometrical. And then this map is once more subjective. So once more, I get these things as a combination of linear forms here, which are such kind of properties. So a theorem which I have is that really that curve phi 0, 1 is contained in curve P. Well, I should say also in some cases this map is injective. In some cases this map is injective. So it's P equals 3 and P equals 2 for prime numbers. So then all elements here are already geometrical. So then I obtain elements of here geometrical, and also this I obtain geometrical. So this means that these things, at least using these two things, I can obtain all coefficients. So I can obtain all coefficients here as a linear combinations of coefficients which are from here. For if I take p equal 2 or p equals 3, and in case p equal 2, this will be all coefficients here, which are unramified everywhere, and here we'll have some additional. So say all periods of mixed state motif over spec Z, one can obtain as a periods of mixed state motifs or as iterated integrals in this form. But one should take only some special sums of such expressions and also of such things. And also one should take only the special sums. And this somehow generalizes. So now I will try to prove this theorem. So, well, I just gave G, Q, mi P acts on pi 1 Q minus 0 infinity plus mi P, and here 0, 1, L. And I suppose that L does not divide P minus 1. So this I should suppose. And then this map which I get, Li, U, Z, Z mi P 1P L to Li X Y0 Y P minus 1. This is ZP star equivariant. ZP star is a Galois group of Q mi P over Q. So with this I can get such thing. Then, well, these things are generators. And in fact, one can describe it here. You have generators, say, 2k plus 1 in degree g, g between 1 and p minus 1 over 2. This is a free algebra. And you can calculate the image of such generator. This is 1p to 2k, 1 minus p 2k, y0 x 2k. This means that you take bracket of y0 with x and then once more with x, etc. this number of times. Yj with x 2k plus yp minus j x 2k and plus something which contains more elements, more y's, not only one. In degree 1, it's very simple. It just goes to y plus yp minus 1. And now if I call these elements z 2k plus 1j, I can prove the following things. That z g, this is a Lie subalgebra generated by z1. Here's how I make this. Here's g1, z2g, and so on. Zng is free and freely generated by this element. So if I cannot prove that all this image is free by these elements, but I fix G here, which somehow corresponds in degree 1 that you take a dual 1 minus CPG dual, and then you take perhaps iterated integrals dz, z minus CPG, and after dz over z, something like that. So these things will be free. And now it's second things that if I denote by A different from G, A Lie ideal of image phi 01 generated by all z k a with all k and all a except a different from g. So it's a Lie ideal. I can prove such thing that the intersection z is has only one element. So now, having these two things, I do such thing. Here I have graded Lie U Z mi P 1 over P L. Here is image phi 0, 1, surjective. Here I have a map Li U Z 1 over P. And this is, in fact, if this is generated by element 2k plus 2k k for G between 1 and P minus 1 over 2, this is generated by some elements like Z for k equals 1, 3, and so on. So here I divide it every time. Because of this relation, I can divide it by these ideals, and I will end in a free algebra just by this for G equals 1 to P minus 1 over 2. And then everything, this is, has also something degree even. So the generating degree even go to 0, and this goes to corresponding ZG to k plus 1 goes to corresponding here to k plus 1. So I get a map here, and because this was equivariant, such ZP star equivariant, and this also, all this will be commute, and I get this psi here, which will be surjective. So this somehow proves. So the last example which I should like to mention is well, also very, it's just my beginning. This x on pi 1 q minus 0 infinity plus mi p 0 1. So I have this map V Li U Z mi P 1 over, no, P is 5, so here is 5 now. 5, and here I will have Li x, y 0, y 4 with the strange bracket. Here the generators in degree 1 is S1, which is dual to Kummer character C5 1, S2, which is dual to Kummer character C5 2. So because it's a free Lie algebra, the bracket is different from 0. Here, this elements goes to 1 plus y4, and they goes like that, y2 plus y3, but the bracket is different from, is 0. So you are missing one period here of mixed state motive. You don't get from this picture, from iterated integrals, from 0 to 1, and this with this pulse. So, So I considered the action of the same group on pi 1 minus 0 infinity plus mi 10 and 0 1. So you have graded Li, but here is a better reduction at 2 at 5. So I have Li, Z mi 5 and 1 over 10. One should invert. I go here to free algebra, to Lie algebra X and Y0, Y9 now with this bracket. And here I have generators 1 minus Xc1 dual. So it's S1, S2, which is K1, C2 dual. I have one other N, which is dual to 2, which appears. And all brackets are, of course, different from 0. Here I have image of S1 is sigma 1, which I can calculate. It's something like plus y nef minus y3 minus y set, sigma 2 minus y1 minus y4, 6 plus y7. And here, sigma 1, sigma 2 is different from 0. And in fact, I can take if I can write in this base, I get one coefficient, I think is y8. Yes, and plus something. So if now this is phi, 0, 1, and if I take now here f, which is just to QL, which is dual, this psi is just dual to y1, y8, dual, and if I compose with phi 0 psi, I have a geometric coefficient different from 0. It will be different from 0 on S1, S2. On this generators will be different from 0. And I, in fact, can show that this psi, phi 0, 1, will be vanish on, it's in degree 2. So it will be vanish on n. This generator avec S1 will be 0, and on n S2 will be also 0. So in fact, these things, this linear form will give, here I have li, u, z, mi, p, mi 5, 1 over 5 surjection. So I will get, so it will be vanished on this thing. So it will be vanished on the kernel. So I will get this coefficient, that it's a coefficient here and to QL. So I constructed now the things which was missing here, because here I cannot get dual to this element. To this element I cannot get from this picture. I get this dual from this picture. So it's geometrical, and morally it would be more or less in periods it would be correspond to iterated integrals, but it should be I think of such things: 10, 1 dz z minus xc8. But it should be viewed carefully, because it could have some part which is a product of logarithms, which still could not ramify and which I don't control. So in this way, at least in this example, I was able to, if I take all iterated integrals here, one is missing in degree 2, which corresponds to this bracket of generators, but I can construct in some way here, in geometrical way. So this is more or less my talk, whether it was something, I don't know. I hope it's not mistake. So it is,
you constructed the bracket of degree 1 generators.
yeah, because say in degree 5, you have 2. In this Lie algebra, you have 2 generators in degree 1 and 3. So the bracket is also different from 0. But in here, if you look, you are missing the bracket. If you calculate it, is 0. So you are missing 1 period in degree 2. So you cannot get these periods from iterated integrals of this form: 0, 1, 1, 0, dz, z, and dz minus z minus xcpi with any order. So if you look here, you have such situation that now this bracket is different from 0. I have calculated twice or 3 times or 4 times, but still can be a mistake. So this bracket is different from 0. So here there is, but the problem is that here you have more ramification. So now, if I take this linear form, I should, it is dual to this element. Here, it will be dual to this element. At least on this element is different from 0, on this bracket. So now I must check that this linear form, which I got, it also vanishes on the kernel of this morphism. So it's enough to check only in degree 2 what is happening. And there are only 2 elements to check, which are somehow not very difficult. Simply image of n is very simple. I think it's y5, and this allows this calculation. So, and before the result, if everything is correct, it means that all periods over spec z, because from z1 over p you can pass to z, you can, all periods of mixed state motive over spec z, you can get as a sum of iterated integrals of these things, of these things, z minus xc3i. And this is rather easy because the map, this map is injective in these 2 cases. But also, if all goes work of these things, cpi for any I, in iterated integrals from 0 to 1, to 1, 0, but only some special iterated integrals which corresponds to linear form, which vanish on the kernel of this map. So, and this, the condition, if I'm writing in this case, it's like for Zagier conjecture of type. So you have some symbols, and the d of this symbol should be 0, such kind of symbols like Zagier writes. But the symbols are somehow indexed by elements of free algebra. So, but it's very similar like in Zagier conjecture. But I don't know if it's yeah, I hope I not made a mistake.